We dropped Mars into Earth's orbit and gave it 34% water, and the result is stunning. You noticed the Moon did not stay bound, it escaped into its own orbit. That's expected. Mars is less massive than Earth, so it can struggle to keep our Moon in tight orbit. The system reconfigured to a new dynamical arrangement quickly. At first the water sits as ice on a cold Mars, entire oceans frozen like blue deserts. But then we start to warm it up, and wow! UAU! What a difference! Initially, the planet reads about minus 63 degrees Celsius in the sim. Fast forward the clock and things change fast. In just under 3 years the global average climbs to roughly plus 3 degrees Celsius. By year 7, the mean is already above plus 60 degrees Celsius. Then the heating doesn't stop. The simulation pushes Mars past plus 80 degrees Celsius, and the surface turns into a white, steaming globe of vapor. Why does this happen so violently? There are a handful of physical feedbacks at work. First, the albedo feedback. Ice is bright, open ocean is dark. As the sun melts ice, dark oceans appear and absorb far more sunlight. That absorbed energy accelerates melting, a classic positive feedback loop. Once the ice line retreats, the planet soaks up heat much faster. Second, water vapor is a powerful greenhouse gas. As ice sublimates and oceans evaporate, the atmosphere accumulates large amounts of steam. That vapor traps outgoing infrared radiation, raising the surface temperature further. In short, more water in the air, stronger greenhouse, more warming, more evaporation. Third, latent heat and thermal inertia. Melting and evaporating enormous volumes of ice and water dumps huge amounts of latent heat into the climate system. The oceans store heat and slowly release it, smoothing and sustaining warming over years rather than letting it snap back. Fourth, atmospheric growth and opacity. The sim shows an increasingly thick, hazy atmosphere. That increased atmospheric mass and cloud/vapor opacity reduces the planet's ability to radiate heat to space, shifting the radiative balance toward much higher equilibrium temperatures. Fifth, Mars's geology and volatiles can amplify things. Moving a formerly frozen rock into a warmer orbit can trigger release of subsurface volatiles and CO2, additional greenhouse components that the sim may add, which further drive warming. Put together, these effects create a runaway-like warming in the model. Ice, dark ocean, evaporation, greenhouse, more warming. That's how a frozen Mars becomes, within years in the sim, a planet that looks astonishingly Earth-like for a while, then too hot, then a white ball of steam. A few important caveats and real physics notes.